Okay, today we're going to talk about Second 9, Objective 12 for Algebra 1 called Graphing Absolute Value Functions. Now some things we're going to need to know. Absolute value function graphs are V-shaped. Our description for this problem, we want to find the vertex, pick an x value one away, and reflect. Now I know this description is kind of vague as far as there's a lot of information there. I just want to make it as short as possible, and I'll explain it as we go through this. The vertex form of an absolute value function is y equals a absolute value x minus h plus k. The vertex is the ordered pair h comma k, and we'll talk more about how that relates to the graph here in a second. Now if we look at some examples here, just kind of on the side here of finding the vertex. Now, the vertex here again is h comma k. A lot of students here think h here is -3 because of the minus sign, but you have to look at the formula. The formula already has that minus sign in there. So if it has that minus sign in there, that means h is a +3 here, k is a +5. So my vertex here would be 3, 5. Okay, similarly on part B here, a lot of people think h here is a +2. But again, since the minus sign is in the formula to begin with, in order for it to become a positive, h has to be a negative, because a negative and a negative make a positive. So here my vertex is actually -2, 6. And then part C again. This a here is just a number that stretches or compresses, but we'll get into that later on. But again, the vertex is just hk. So again, here, again, that's a +1 that was substituted in. And then k is +2. So let's look at some graphs. So number one, I want to graph the absolute value of y equals the absolute value of x plus 3 minus 2. So again, we want to find the vertex. And the vertex here is h comma k. So h had to begin be a -3 in order for that to be a +3. And then k is -2. So we can plot the vertex, -3, -2. Now, the second part of the description says pick a point one away and then reflect it. So when I say pick a point one away, that means we're just going to make a table here. And I want to go one away from the x value of the vertex. So I could go -2 or I could go -4. Doesn't matter. Whichever one you want to do, I'll just do -2. So if I plug in -2 for x, y would equal the absolute value of -2 plus 3, then -2. So the absolute value, -2 plus 3 is 1. So we got the absolute value of 1 minus 2. Absolute value of 1 is 1. Minus 2 is -1. So I have the point -2, -1. Now when I say reflect it, an absolute value graph, since it's shaped like a V, would be the same thing on both sides of the vertex. So if we got a point 1 point away from the vertex, it'd have to be 1 point away on the other side as well. And then we can draw our V. And then we can draw our arrows. So number 2, y equals the absolute value of x minus 4 plus 1. So again, our vertex, h and k, so in this case would be +4, 1. So we go 1, 2, 3, 4, 1. Again, make an XY table. So put in either 3 or 5, whichever one you want to. I'll just pick the smaller one, so I'll put in 3. Then if you need to write it out, fine. If you can do it in your head, also fine. So if I put in 3, I get 3 minus 4, which is negative 1. The absolute value of negative 1 is positive 1. Plus 1 is 2. So I had the point 1, 2, 3, 2. And again, it would be reflected on the other side of the vertex. Okay, number 3, y equals the absolute value of x plus 2 plus 3. So again, the vertex h comma k. So the vertex would be negative 2, 3. So negative 2, 3. And then I'm just going to put in negative 1. So if I put in negative 1, negative 1 plus 2 is 1. The absolute value of 1 is 1. Plus 3 is 4. So I have negative 1, 4, and then I can reflect it. And I know right now it seems like these are always up 1 over 1. That's due to something else in the problem that we'll discuss later. So right now you still need to make a table of just 1 point and then reflect it. So number 4, your vertex would be 1, negative 4. So 1, negative 4. Then I'm just going to put in 0 for x. So 0 minus 1 is negative 1. The absolute value of negative 1 is 1. Minus 4 is negative 3. So we got the point 0, negative 3. And then reflect it over the vertex again.